All right, hello Calculus 1 class. I thought it might be helpful for you if I worked through the Exam 2 review solutions as a video. So I don't know how many parts this is going to end up being, but I'll break it up into short segments and would invite you to follow along. If you don't want to watch the video and you just want to check your solutions, I've posted the PDF as well. So let's scroll down and dive into the first problem. I want to compute this derivative. This is just a chain rule. The outside function, of course, is sinh, and then I will have to take the derivative of the inside as well, following the chain rule. So here we go. Let's do it. So f prime of x is going to be, well, the derivative of sinh is cosh. So the derivative of the outside is cosh. Plug in the inside. So arc sine of x plus x cubed. Then you want to multiply by the derivative of the inside. Well, the derivative of arc sine is 1 over the square root of 1 minus x squared. And add the derivative of x cubed, which is 3x squared. And I look at this, and I'm always thinking about simplifying, but there's really not much I can do here, so I'm going to call that my answer. All right, next problem. I want to do some implicit differentiation. So let's work through this. I'm going to begin just going term by term. I'll begin here with the y squared term. I take the derivative of y squared with respect to x. I'm thinking about y as implicitly a function of x, and so I get 2y, and then I kick out a dy dx. On the next term, on this term, I've got to do the product rule. So I've got a product of x squared times a y. So first I'll take the derivative of the x squared, which is a 2x times a y. Then I'm going to add, and I'm going to take say x squared times the derivative of y, which is just dy dx, equals, and then I've got to do the same thing on this side, product rule again, so I'm thinking about it as 3x times a y. So the derivative of 3x is 3 times y is 3y plus 3x times dy dx. And so at this point, it's just a matter of algebra. It's just a matter of solving for dy dx. And so to do that, we want to move all the terms that have a dy dx in it over on one side. So this term, and this term need to be together. We'll move this term across. And so I'm going to go ahead and pull everything over and factor out the dy dx. So I'm going to have a 2y plus an x squared minus a 3x all times dy dx. If you're having trouble with the algebra there, pause this and work it out yourself. And this equals, what, 3y minus 2xy. And so now at this point, I'm going to just solve for the dy dx. I've got it. Dy dx is 3y minus 2xy divided by 2y plus x squared minus 3x. And that's it. All right, so on to the next one. Let's do one more, and then perhaps I'll pause this video. Let's see. So I want to do dy dx given this particular function. This is an interesting looking function. The key thing that you should notice, though, is you have a variable in the base, the x, and then a variable in the exponent, and so that tells you I've got to do logarithmic differentiation to be able to solve this. None of my known formulas apply to this. So I'm going to begin by studying natural log of y equals natural log of x sine of 2x. I'm just taking the natural log of that equation, and now I'm going to use the properties of logs to simplify this. So I can say ln of y is sine of 2x times ln of x. Now I'm ready to take derivatives. This is a different equation than what I started with, but I'll be able to get y prime out from this. So let's begin. On the left side, the chain rule says it's the derivative of the inside over the inside, so y prime over y equals, on the right side I have a product, so the derivative of sine of 2x is going to be 2 cosine of 2x using the chain rule times ln of x plus sine of 2x times the derivative of ln of x is 1 over x. And so finally I'm going to get y prime is my y, which I'm going to go ahead and write in terms of x sine to the 2x, times 2 cosine of 2x ln of x plus, I'll just say sine of 2x all over x. And so there's my solution. So I'm going to stop this video here, and I'll pick up the next